many of the problems that psychologists ask people to solve require insight, a change in a frame of reference or in the way elements of the problem are interpreted, and the process by which insight occurs is not very well understood. Whatever it is, it appears to play some role in what we call creativity. So what is this idea of creativity? Well, basically, and let me pick up the previous one. Although the term is difficult to define precisely, psychologists agree that creativity has to do with some way to appropriate novelty. That is, originality that suits some purpose. Appropriate ideas that lack novelty are mundane, and conversely, original ideas that do not address some problem in a useful way are bizarre. But cognitive scientists talk of creativity as consisting of some combination or recombination of knowledge, information, or mental representations that can be used to solve a problem, etc. So I'm going to fast forward to the bottom paragraph there. The experience I'm describing is a textbook case of incubation. If you basically sit on something and you have what's known as an aha moment. So for instance, I'm going to Google an image here, if you'll indulge me. I should have had this ready. I'm sorry. Sometimes things just occur to me. Of these chimpanzees. These are Kohler's chimps. And what they were trying to do was get to a banana that was hanging from a tall platform. And here's what they did. You can see that they became increasingly adaptive. You see that middle photograph there. These are chimpanzees, animals, that put together boxes in order to retrieve a banana that was hanging from some kind of tethered rope there. And this dates to the 50s, I think, so we're going back quite a ways. You could call this an insight problem. They had an aha insight on how to grasp this piece of fruit. So the process by which we might sit on something and resolve how to get at it would be one of incubation. These chimpanzees, we can't know what their process was, but they certainly found the right solution. So Smith and Blankenship offered one empirical demonstration of incubation effects by means of picture word puzzles called rebuses. After the participants had solved 15 of these, they were presented with a 16th puzzle, which had a misleading clue that induced fixation on something that was incorrect. They were later given this critical rebus a second time without the cue and were again asked to solve the puzzle and also to recall the cue. Control participants saw the second presentation of the rebus immediately, but experimental participants received either a 5 or 15-minute break, during which they either did nothing or were asked to complete some kind of demanding perception task that kept them from continuing to work on that rebus. The authors predicted that those that were given longer filled intervals, which they had to do something, would be more likely to forget the cue and thus solve the rebus. And in fact, this pattern of results is exactly the one they reported. So if I can allow people to go away and just marinate on it and maybe not focus too heavily on something that's germane to the task, like listening to the music here, they've got a better chance at actually solving it. However, most empirical studies fail to find positive effects of incubation. It's not that it's something we can necessarily demonstrate. But one thing I always tell my stats students and a lot of other students that I have is that I really prefer Monday, Wednesday, Friday classes to Tuesday, Thursday classes, because you've got more incubation periods. You're just exposed to the material for 50 minutes and then you can go away and sort of let it marinate for a while. The disadvantage of a once-a-week class or a twice-a-week class is you've got too much going on without any breaks. And that also interrupts the congealment, if you will, the sort of cerebral hardening of those neural synapses that form information.